Subunit 3.2, Formulation and Pre-Phase A. The beginning of the life cycle is the formulation period. And so the formulation period involves defining the system requirements and analyzing various concepts and technologies capable of meeting these requirements. So this is all of the early phases that you're going to see in the life cycle. The goal of this period is to identify a single concept that optimally meets your defined requirements and objectives while staying within the cost, schedule, and any other constraints that you've identified for the project. So at this end of this formulation period, you've kind of started out with maybe a bunch of options that were able to meet your high-level objectives that the stakeholder wants to accomplish. And that by the end of this phase, you've kind of necked it down to one specific design that you'd like to go forward with, one specific concept. And so at the end of the formulation period, you'll take that selected concept and you'll make sure that it's mature enough so that the stakeholders can look at it and say, yeah, we think that this system has been developed and matured from a designing standpoint enough that you're actually ready to enter this implementation phase where you're going to go ahead and now construct that system and deploy it into operations. Pre-phase A provides an early opportunity for stakeholders and engineers to discuss various concepts that can fully or partially meet the stakeholder-defined objectives. So, in pre-phase A, you're looking at numerous concepts, and you may think, well, why look at concepts that don't fully meet the stakeholder-defined objectives? Well, you may find that some concepts you can come up with aren't fully capable of meeting the objectives, but in a dialogue with the stakeholders, you might find out that they'd be willing to live with that kind of system if it maybe could be done a lot more cheaply, a lot more simple to design. And so you don't want to only look at concepts that can fully meet their objectives. You may want to look at some that don't fully meet them, but then engage in a dialogue about how important would it be if you didn't meet one specific objective out of the number that they've defined. So specific activities that happen in pre-phase A include a discussion between the stakeholders and the engineers to define the system objectives and the priority of those objectives. A discussion between the stakeholders and the engineers to define these evaluation criteria and the relative importance of those evaluation criteria that are going to be used to look at these alternate concepts and decide which one is the optimal one to go forward with. And an identification and evaluation of all these alternate concepts and analysis of which ones fully or partially are consistent with the stakeholder objectives, and giving the stakeholders some feedback about those concepts and how they've been matured. So let's go on and talk about a couple examples. So I'm going to go through each phase. So for pre-phase A, I'll use the space shuttle as an example. And now this is a little dated of an example. I agree. It's from the 1960s. And so back in the late 1960s, there was already a thought about building a space shuttle to follow on after the Apollo program and what was going to be next in human space flight. And so one of the options was, well, maybe a space shuttle, a way to take people and cargo into orbit and bring them back as a next evolution of human spaceflight capability after Apollo. So pre-phase A, and you can see on this chart, involved a lot of studies and analysis of many different concepts. And so again, if the high-level requirement was to take cargo and people into orbit and bring them back to Earth and to be reusable, those were some of the initial requirements, then you could have many different types of vehicles that could do that. And you see on this chart, you see a vehicle here in the upper left. That's a vehicle with a small space plane up on the top, but it looks like a regular Delta or Atlas rocket underneath. You see other very interesting things, the Triames, which is the middle vehicle. That's 3 rockets glued together, each one capable of lifting the whole stack for some amount of time. It drops away, comes back and lands and is reusable while the other elements continue on to orbit. You see a space plane in the middle there where you have the space plane surrounded by a giant fuel tank. The giant fuel tank actually can be, after it burns out, flown back and landed and reused. And so at the beginning of the space shuttle program, the idea was that the vehicle would be totally reusable. And in pre-phase A, all the concepts that were developed had to be totally reusable vehicles. And so it turned out that that requirement during pre-phase A was found to drive the cost of the vehicle sky high. The development of a vehicle that's fully reusable, all components, was going to be extremely expensive. And so when the space shuttle design was finally firmed up and decided on as they were leaving the formulation phase to go into implementation, that vehicle looks a lot different. That's no longer a fully reusable vehicle. So pre-phase A served its purpose, a lot of these concepts ended up showing that the cost was going to be very high. It's going to be technically very difficult to build a fully reusable vehicle. And so the agency was able to then go back and say, well, let's change that requirement and say partially reusable, and let's see what kind of designs we get out of that. And that ended up in the final design of the shuttle. So pre-phase A is a critical time to look at many different concepts that can meet your objectives and help drive out whether those objectives may be too onerous to meet and maybe should be relaxed, or which one of those concepts can most optimally meet the requirements. So we're going to talk about these technical reviews throughout the life cycle. And the first one happens here in pre-phase A, and it's called the Mission Concept Review. So the Mission Concept Review is your first big technical review. External team comes in, and they're going to look at the things like the result of a scoping exercise. And scoping exercise, we go into that in more detail in another unit. But you think of it here as just, it says here it includes stakeholder-defined system objectives. And so think of it as where the stakeholders have defined, what do I want this system to be able to do? In the end, when you put it all together and fly the satellite in space, what are the primary objectives as defined by, and stakeholders could be scientists, they could be people at NASA headquarters, they could be people elsewhere in the federal government who have helped define what does this system need to be capable of doing to be successful. And so that's, we'll talk again more about scoping, but this mission concept review will look at whether you've clearly defined the stakeholder expectations for the system when it becomes operational. So you're also going to review things like the technical analysis of all these alternate concepts that you've developed that can either fully or partially meet those objectives. And they're going to want to see that at least one of the concepts that you've looked at is fully capable of meeting the defined objectives the stakeholders have laid out within all the other constraints, within the budgetary constraints for this system development, within the schedule constraints when it needs to be launched by. So this technical review team is going to look to see, do you really have a concept that could actually meet all of those objectives and constraints? The review team is also going to be looking at performing a programmatic analysis of these alternative concepts to establish that there's at least one that, again, both technically and from a cost and schedule standpoint, can be executed. So this is a technical review team, but they're also wondering, do you really have a feasible concept here that, given the amount of money we have for this project and given the time we have to complete it, does this technically look like something that could be done with that amount of cost and schedule that you've been given? So they do bleed over into some programmatic analysis, because technical experts are also folks who really understand how much it typically costs and how long it takes to develop these kind of systems that they're reviewing. You're also going to look at the initial concept of operations. Again, we'll talk more about what a concept of operations is in other units, but for now, think of it as a description of how the system will be operated. So it's very important at the beginning of the life cycle to lay out kind of a picture of how the system will be operated throughout its life once it's completed, because that picture will help you in defining some of the requirements for the system, because you're going to understand a little bit about how it needs to work. You'll understand how you need to build it to be able to work that way. So it's important early on to develop this concept of how it will be operated. The review team will also be looking at the criteria that are being used to evaluate the concepts and the priority that you've established for those criteria to make sure that they agree that those criteria are set properly and are really helping you drive out what is the optimal concept to go forward with. And then there's also a preliminary assessment of key technologies that might be required in the development of the system and any risks. So it's going to be important. Technologies here, we're talking about something you need to do. Maybe you're the James Webb Space Telescope and you're going to have to build a mirror to be able to do the science that's going to be bigger than any mirror that's ever been flown in space. And so that's considered a technology, something that's harder or more difficult or new that's never been done, that you want to make sure that on the ground you've matured that technology, that you've worked on how to make a mirror and actually maybe practiced it on Earth and tested it on Earth before you get too far into the life cycle, to make sure that that you're capable of doing it, because you don't want to find out later that you don't have the money and the time to actually finish it. So early on you need to define, are there any key technologies that maybe have never been flown that I'm going to need to make some investments in early on to be able to test out on the ground, and because that's going to eat up a lot of the early phase money, and so that has to be defined. You also want to look at any of the other risks that might be associated with developing the system. So there could be areas where the technical review team says, boy, you've got a really aggressive schedule, or you've got a really aggressive schedule specifically for doing some part of this development. And so they want to really make sure that you understand what your risks are, and they might help you identify some of the risks that they think there's going to be in completing the system on time and within budget. So those are all the things that are reviewed here at the Mission Concept Review. Again, this technical review team will be coming back throughout the life cycle, and we'll talk about them again and again, coming in to do technical reviews to make sure the system is mature enough to continue to progress through the life cycle. There are no additional resources for this subunit. Feel free to skip ahead to the next video.